Just wanted to give you a few tips for going through the Groundwater Lab. So there is a little math in here, and I don't want you to get scared of the math. So the math is just putting some numbers in some formulas and putting them through your calculator, multiplying, dividing. So don't let maybe the complexity of the equation throw you. Realize that you can just plug in some values and work through your calculator, and you should be able to get the right answer. But there's a couple things you're going to do in lab. So the first thing is there's some groundwater maps here. So there's 3 versions, different years, and each of these little dots represents well data. So you assume a well was drilled there. And this is the elevation of the water table, not the surface, right? And so what this does is give us a shape of the water table, and then we know that water is moving from higher elevations to low elevations. So that gives us a general idea of the flow of the water in the subsurface. So that can be useful, and certainly when we look at contamination events and things like that, it's useful to know what direction the water is moving because the contamination will move that way. So you're going to look at these 3, you're going to be referencing these here and there, so you'll have to scroll back up for these. But the first couple questions are just asking you about the general flow of the groundwater, looking at some of the values there. And so you'll look at the different years of that information and determine where the flow is coming and why it might have changed. You're also going to look at how water levels have changed. So you're just comparing the elevation of the water table at a couple different points. And then there's something else that's useful when we talk about groundwater, and that is the gradient. So we talked about gradient way back when we did maps. Topographic maps is basically how steep the surface of the earth is. This is kind of the same thing. It's how steep the surface of the groundwater table is. So it's a very similar calculation. What you'll want to do is find 2 wells, figure out the elevation of the water table at each of those, and the horizontal distance. So we're going to take the elevation difference and subtract those values. And then we're going to divide that answer by the distance in miles, and that'll give us a gradient of feet per mile. So the higher the value, the faster the water will travel in the subsurface, and the lower the value, the slower. And so it is one of the things that dictates how water moves through the subsurface. And so I'm going to ask you to do a couple of those. So you're going to go back to those maps, and you're going to find those points, figure out the difference in elevation, and figure out how far apart those wells are, and then you can calculate the gradient. And so you'll do that for the 3 different maps, and so you'll have that information there. And then another piece of useful information about groundwater is how much is available down there. So it's useful to know its motion and direction and speed, but also how much is down there, because of course we need to use that water to sustain our life. And so we can do that with this calculation, and it's just the area of the unit that is holding the water. So remember, we talk about porosity and permeability. So certain layers of rock will hold water. So we can define that area. We're going to define it in acres. So that'll give us kind of a length and a width. And then if we know how thick that sediment is that's holding the water, right, we can then figure that out and then multiply it by the porosity, how much open space there is. And so that'll give us then the amount of water available in that unit, and then we can use that to evaluate how much water is available for where we live, right? So here's kind of an example of that. So you'll use something like this. Don't let, once again, the formula throw you. You're just going to do the area. So I'm giving you some of that in a question. So I want to know length times width, right? So here it is here. You have to convert that from this will give you square miles into acres. Okay, so there's a formula here for that. So read through this carefully. The information is here. If you rush through it, you're going to be like, ah. So you get the square miles, you multiply it by 640, and you have this. The thickness of the area is just where the layer is at depth, right? And how thick it is. You just multiply that, and then the the porosity is just given to you. So once you multiply all those out, you're going to get a term in acre feet. And so that's the value of how much water is potentially available there. Then we want to know if we use a certain amount, how long will it last? Or if we change the permeability, how does that affect how much water is available? And then finally, what you're going to do is a quick little calculation to determine how fast and where the water pollution might go. And we're going to go back to that gradient that you calculated. And so what we can do is, if we look at a map and we know how the water is moving in the subsurface, we can use that to determine who is polluting, because we know what direction the pollution must be moving. And then if we know that, we can calculate the velocity, how fast it's moving. And so you will need a gradient. Luckily, we've already calculated that, and we'll use one that you previously did. And these other values, so this is where I don't want you to be like, oh my gosh, I don't know what big words and this looks very complicated. I'm giving you these values. The hydraulic conductivity is another property we need to determine the velocity of the groundwater. You're just going to plug that in. Here we're just plugging in a number, right? And then this is the only thing this is doing is changing our gradient's units. Our gradient units is in feet per mile. I want it in feet per feet. So we just have to divide the gradient that you calculated by 5,280. So it's just a unit conversion. So you're plugging in that's given to you, that's given to you. You're just going to find the gradient from a previous question and plug it in, and voila, you will get an answer. And then from that, because we know the speed, if we know how far away the polluter is, we can tell you how long it will take for it to go a certain distance. And so that's what this last question is going to have you do. So there's a little bit of, like I said, math, but it's just mostly, subtracting, multiplication, division. And even though some of the formulas look intimidating, they're really not. The values are there. Just plug them in and you should be okay. So that was my math pep talk. Anyway, otherwise, you should be good. And as always, if you're having some struggles or you can't figure out something, please contact me and I'll help you out.